Welcome. My name is Quentin Clark. I'm the Vice President of SQL Server, responsible for the database, effectively. So the core RDBMS, OLTP, data warehousing, manageability. I have two commitments for you at the beginning of this. One, I know we're already running a little late at the conference. Here, like 3 hours in, we've already managed to get ourselves late. And I won't make you any later for lunch than you already are. So that's one. The other one is we're going to spend half our time in demos. Going through, I have a team of demoers waiting in the wings over there. So we're going to spend half the time in demos doing in-depth work in terms of what is actually coming in the product space. So to follow on from the keynote, there was a discussion going on around data, the explosion of data. I'm not so sure about kaboom exactly, but there's a lot of conversation going on around how to take data, transform it into information, really get value and insight out of it. And that's been a theme for SQL for a really long time, and it continues to be sort of the major axis in which we look at our business and what we do for our customers. Today we talk about mission critical, the fundamental pieces of the product that just have to work correctly, whether it's security or performance or availability, but that sort of bedrock of building solutions around data and data management. We talk about cloud on your terms. We believe from talking to customers that the cloud phenomena is not just a matter of suddenly waking up one morning and rewriting all of your applications, but it is a matter of getting there from where you are on your own terms, evolving, if you will. Taking an application and starting to use some cloud services as part of the application, extending to the cloud, or doing burst capacity to the cloud are examples of what I mean by evolving there and not just rewriting from scratch on a new paradigm. And third, it's about insight. It's about changing the conversation around how to empower people that need the information every day to make good decisions for their business. And we talk about these three axes, and we'll be speaking about SQL Server, codenamed Denali, which is the next major packaged product that's coming out in the future. And then we're also talking about SQL Azure. SQL Azure as it is today, and then SQL Azure as it's coming out in the roadmap over the next year or so. So let's start with mission critical. I always like to start this conversation with a recognition that it's not just about the big things, big availability features, that kind of stuff, but it's also about the small things. There are things like security roles that matter a ton in terms of IT's ability to do the right kinds of deployment. There's other things that aren't necessarily obvious mission critical, like distributed replay. We have a feature we're delivering in Denali, which allows you to take your application in pre-production, not the production system, but the one you're using to test and validate changes, and ensure you can drive enough load against that to really simulate the kind of loads that these production systems see. It's not a big thing. You're not going to find a big ad in the airport about it, but it's the kind of thing that we have to invest in because it's what you guys actually do day to day, to validate that the platform you have built is in fact ready for that kind of production. And of course there are the big things. In the area of performance, Apollo. We have a project we internally call Apollo, which is a new column restore, which will get between 2 and 100 times query performance on specific kinds of data for specific kinds of pattern, particularly those that lend itself well to data warehousing, star schemas, that kind of thing. Here we've taken a different approach than the market has so far. Today, if you're using a competitor's product, there's one of sort of two avenues you can have. You can take a very specialized thing, which is for data warehousing only, and does not actually support full SQL semantics, and you can get something out of that performance-wise. Or you can buy a product that sits in front of your database system and effectively is a cache to do acceleration. We don't think that's the right architectural approach. What we've done with our column restore is we've taken it and embedded it deeply into the RDBMS. The reason we did it is because you can, like any other table, turn on index type and then get the performance and value out without having to rewrite your application, without having to replan how your physical database functions. So that's an example of the big thing. Again, the performance, there's also the small stuff. There's things like increasing the performance and scalability of integrated full text search, or the scale of file stream. So across the spectrum of the product, you're going to find investments in availability and performance and scalability. The hallmark feature in Mission Critical for the Denali release really is Always On. Always On is a set of technologies that provide the capabilities you need to increase availability, increase data protection, and do so in a way that makes it easy for everyone to attain. First, there's a fundamental sort of reboot of some of the technologies we have. Today, with mirroring and log shipping and clustering, etc., you kind of got to become an expert in the database and how the database functions in order to set up the right kinds of HA solution. With Always On, we have the flexibility built into the product that lets you achieve the next level of availability by using multiple replicas and faster failover and building on Windows Core to minimize the kind of critical patching you have to do to have a system which is going to have just sheer availability at a higher level than what you have today. And the other side of this is using things like asynchronous replicas for more geo or regional kinds of scenarios, and using things like backing up from secondaries. You get to ensure a higher level of data protection. You have potentially more and one and more non-local copies, and then you can build a backup infrastructure that allows you to ensure that your data is always safe and moved into places where you can ensure integrity, even if you have catastrophic site failures. And we're doing all this around a theme and a drive to make it much easier to achieve. You'll see in the demo here shortly, we put a lot of investment into ensuring that when you set up these HA scenarios, that you get it right from the beginning. We walk you through every step. We do as much of it as we can possibly do under the covers. And then from that point forward, in an ongoing operations perspective, we ensure that you have the right experience to make sure that the availability is really there. We often find when we get into customers and we talk with them, there are these situations they have where they'll do a manual failover, but they won't really know that they have a data loss because they were using log shipping and they didn't have the second copy fully up to sync, and they orchestrated failover, and they're wondering what happened. Well, with the technologies we're building with Always On, the experience we're building around it, we can avoid those kinds of situations. Furthermore, the part of the goal in terms of improving the experience around Always On was to raise how easy it is, lower the bar in a way, make it easier for people to get the highest levels of availability. As SQL Server has found its way into enterprises, our customers have realized there's no such thing as an unimportant database. It kind of really doesn't exist. And so they're looking for the highest levels of availability. They're looking for more tier 1, mission critical kinds of capabilities and solutions for all their applications. So without any further discussion, let's get Gopal Ashok up here as a product manager to come give us a full tour of Hadron.
Thank you, Quentin. So what I'm going to demonstrate here today is how, using Always On, you can easily deploy and manage a high availability solution that provides the required uptime for your application and also provide the data protection that you're looking for, even through all kinds of failure. So you want to protect against any kind of server failures that happen locally in the data center. You want to protect against the data center failure itself, and also be protected from any kind of disasters that can happen. And I'll also walk you through the experience that you can get in terms of offloading reporting workloads from your primary server onto the secondary instances. So everything in Always On is very nicely integrated into Management Studio. So what I'm using here are 4 standalone instances of SQL Server, all running on HP Blade servers. So as you can see, if I go to the primary instance, you can see the Always On high availability node. With Always On, you have this new capability called availability groups, which is what provides high availability for application databases. So let's go ahead and deploy the solution and see how this all works. So Quentin mentioned about making things easy. So we have a very nicely integrated wizard that helps with the deployment of the solution. So let's go ahead and walk through this. The first thing that it asks for is a name for the group. And over here, this is something that is new with Always On, which is the ability to group databases together for failover. And this is extremely important from an application perspective because most applications have multiple databases associated with it. So what I can do here is I can go ahead and select these two databases and group it together and say I want to fail it over. And over here, this is where we can gather the rest of the requirements that I just stated. So I said that, hey, in case a primary server goes down, I want to be able to automatically fail over to another server within the same data center. And what I can do here is I can come and say, I want to automatically, all right, which one is it? All right, I want to automatically fail over to the second instance. And I also said that I want to have data center protection. So I can add yet another instance of SQL Server. And this is something new that you can do again with Always On, is to have a second copy of data that is synchronously protected. So you get additional data protection, which you were not able to get before. And lastly, I want to have a disaster recovery site, right? So as you can see, I've added multiple secondaries here. So it's one integrated solution which gives you up to 4 secondaries, and you can build out the solution based on your requirements. And in the case of disaster recovery, I've made it asynchronous because typically the sites are far off and the latency is pretty high. So now I have all these secondaries sitting around. So are they just going to sit around and wait for a failover? No. So with Always On, we have active secondaries. So what I can do here is I can come in here and say if any of these instances are in a secondary role, make it readable. So as you can see here, I have 3 options. So here I'm saying, yeah, for this particular instance, don't make it readable. And over here, I'm just saying, yes, make it readable. And there's a subtle difference here, which means any application can actually connect to this instance. And if they execute a query, you will get close to real-time data. But if you try to execute any kind of updates or something like that, the application, obviously, that particular statement is going to fail. To make the experience even more seamless, what we have this concept of a read-only intent. And what that is essentially is you can specify an application as a read-only application. And with that, and you specify that through a new connection string property that we have, so the server knows that this is a read-only application, and we actually do a lot of things behind the scenes to make the application failover experience seamless. And with active secondary, I can also offload the backups. And we have a set of flexible policies that you can choose in terms of where the backup needs to run. But at the end of the day, regardless of where the backup is taken, you can stitch it back all together nicely, and we have a new recovery wizard that basically gives you a visual timeline of all the different backups from all these different sources. And over here, this is where we define the group listener. So essentially what a listener is a virtual name. And what the virtual name does is it makes the application connection experience very seamless. So the application will basically connect to the virtual name, and depending on whether the application is a read-write application, it will be redirected to the primary, and in the case of a read-only application, it will be redirected to the active secondary. I'm going to skip this step, and I'll come back to it later in the demo. And over here, this is the initialization of the secondaries. This is just a one-time step, doing the initial backup and restore. From that point on, we will incrementally send the log blocks over the wire. So this is just a one-time step. And the last thing that we're trying to do here is that, based on, like Quentin said, we're trying to make it very easy from a DBA perspective. So we do a lot of the validation checks that can potentially cause the deployment to fail and make sure that everything is in the right place. And then I can go ahead and deploy the solution. So it's as simple as this. And the wizard basically will go through, create all the group, initialize the replica, make sure that all the databases are synchronized, and start data synchronization. So as you can see, it's also starting behind the scenes some events or traces that you can go and check later during runtime. There you go. Within a few minutes, I was able to go ahead and deploy the high availability solution. So if you come here, you can see that you see the availability group that I just deployed with the replicas and everything. But what you will also notice is that I have another group that I pre-created. And as you can see, then you can have multiple availability groups that you can use to differentiate your applications and deal with them separately. So what I have here is an availability group for the Microsoft Dynamics CRM application. And I have 2 databases associated with the application. I also have a listener that I've created that is associated with this group. So let's go ahead and look at it from an application perspective. So this is the Dynamics CRM application. This is the dashboard. But what I kind of want to focus on is the reporting side. So as you can see here, I am actually directed to the secondary. So I'm actually reporting off of the secondary right now. To show you how the application failover experience works, what I'm going to do now is I'm going to failover from O2 to O3. So I'm going to make the O3 server the primary and see what happens to the report. So I'm just going to execute the failover here. And going back to the application, if you reconnect during the application, during the group failover, the application will get a disconnect. But as soon as you retry after the failover, the application will reconnect back successfully. So at this point, and the failover typically takes about a few seconds. So what I'm going to do is I'm going to go ahead and retry the reporting server and see what happens. And over here, the client driver will basically detect that, okay, the server that you were connected to is actually down, and it will actually automatically redirect it to the new secondary. So that's a kind of seamless application redirection that you get with Always On. And lastly, I want to leave you with the manageability story. So all this is great. How do you manage the system? So what I'm going to do is we have the dashboard that will give you a very nice view of the system and all the different states. And it's integrated into the Management Studio. So over here, it'll tell you if everything is green, if something goes wrong. It'll also tell you if any of the states are missing. So the last thing is, in terms of planned failover, like Quentin said, you want to know whether what you're doing is the right thing. You're failing over to the right server. So we have a really nicely integrated failover wizard that basically will tell you which server you want to fail over to and if everything is working correctly. And after the failover, you can actually bring everything back up. So what you're seeing here is a very nicely integrated solution that gives you the required availability, but without the cost and complexity. We have a couple of breakout sessions that we have right after this. Please do attend that, and we can give you a lot more details. Thank you very much.
Thanks, Gopal. So Always On, big step forward in terms of availability management, not just from the standpoint of the capabilities it offers, but also from the standpoint of how easily you can set up and configure it for all your applications. Big step forward there. So let's talk about the journey to the cloud. The cloud is, there's infrastructure, there's platform components, and of course there's finished good software services as well. In the SQL world, we think of this as a set of capabilities that are symmetric between our on-premise offerings, the box product, and SQL Azure. So like the core RDBMS itself and reporting services, another example. And then there's a set of new platform capabilities, things like data sync or the SQL, the Windows Azure Marketplace Data Market, what used to be known as Dallas, where data sets are offered and consumable through an OData feed to integrate into your applications. And then there's applications that will be built upon this platform and then sold as finished goods, things like CRM Online and SharePoint, those kinds of things. When you think about the cloud in your terms, it's a matter of how you're bringing these things together and how you're using which components when. Let me give you a couple of scenarios to paint this out. If you have an application that you want to do data exchange with a partner through OData, and you're going to use SQL Azure to do it, and you use sync services to get the data up and down, you're suddenly a cloud app. Yeah, your main application may still be running on-prem in a traditional way. Maybe you've even virtualized it into a private cloud. But at that point, you are consuming the cloud on your terms. You're evolving your applications to consume the components of the new cloud offerings in a way that works for you. We have customers who are themselves ISVs. They're transforming into software as a service vendors. And their initial beginning of this was to take their system and host it and deploy it themselves, multi-tenancy, lots of databases. Well, what they're starting to do now is using SQL Azure as burst capacity. So as they're taking on, they do promotions or they take on large sets of new customers at once, they're using SQL Azure as a way to give them this great capability to onboard very, very easily using our infrastructure and our scale to be able to do that. That's another example where it's hybrid. It's not about them rewriting their app. It's about them using the cloud in their own terms to do it. And we also have examples where customers are developing new apps in a new way because of what the cloud offers. We have a customer who sells tickets online, and they have this problem where they have to sell at a stadium very quickly. So a stadium could have 40,000 seats in it for some concerts coming up. And they want the customer experience through the website to be as soon as you walk up, you can get in, get your ticket, and get out very quickly. Well, imagine that problem for a second. You know how this goes, right? You know, Lady Gaga or something opens up a concert, tickets will be sold at, 1 p.m., and then everyone at 1 p.m. is looking to get the best tickets. Well, that means you have thousands of concurrent users all trying to get access to an app, literally within the same seconds, right? Starting at the same seconds and trying to get through that process within minutes. And it's a fairly obvious thing to state, well, if they can't do it, if they're sitting there in some queue, some of them will give up, this kind of thing, right? They don't necessarily sell at the concert as quickly as they want to. They use the cloud for it. They've actually redesigned their app, rebuilt an app to spin up SQL Azure database instances in parallel, literally hundreds and hundreds of them. And their app logic, as they walk their customers through their experience, depending on price level and where in the stadium, they've partitioned the stadium into little sections of seats, and they can actually, in parallel, run thousands and thousands of customers through and sell at the stadium literally within minutes. When that activity is over, they shut down all the SQL instances, and they're done. So that's a different app pattern and building for capacity that they otherwise really couldn't do. So the cloud is not one of these things where you have to read the papers developed by Bing or Yahoo and rewrite your app to look like one of those. There are actually very few applications in the world that are quite of that scale and nature. But it is about what is the cloud going to offer you, and how do you get from where you are today and consume the right pieces to move your business forward and provide value tomorrow. And for these solutions, of course, we have a variety of assets that are in play. We have SQL Azure, database role, reporting, synchronization services, etc., that are components for you, building blocks for you to build on. You have a variety of services like data sync and the architecture of OData that lets you achieve these scenarios and use additional kinds of value-added services, including the data market, to start to consume some of these cloud services in a different way. And last, but certainly not least, there's an important aspect to this, which is about development. Having all these capabilities, you have to have the right development tools that let you target these things and let you deploy between these solutions. We have an effort that we call Juno internally, a new set of tools integrated as part of Visual Studio for the SQL platform that we've been working on to ensure the right kinds of continuity experience across the on-prem solutions and the cloud and across our workloads. So Juno is a new set of add-ins into Visual Studio, into Visual Studio's IDE, that you can use standalone or you can use integrated other Visual Studio projects that are comprehensive across the workloads in SQL Server. So you have an integration between the analysis, the reporting building, for example, and the database building. And then you have a set of capabilities that are built in a very modern way in terms of a fundamental reapproach to our tool story. So it's modern, has a language services. In fact, we even componentized the core DBMS engine so that the parser and lexer of the database is the same one that we use in the tools, so that the IntelliSense works and all that stuff, so that it's even version aware. It knows which version of SQL or Azure you're using and can help with the syntactic and semantic correctness of the application along the way. Well, enough with me talking about it. Let's invite Roger Doherty up to come give us a full tour of that. Roger.
Thanks a lot, Quentin. So we're going to take you through a quick tour of the new SQL Server developer tools, codenamed Juno. And we're going to switch over here. And where we're going to start at, just to kind of emphasize something that Quentin said, these new SQL Server developer tools are going to make it possible for you to build very, very powerful database solutions, build them, deploy them, manage them very efficiently. And you can do it in a way that targets both your on-premise environment or the cloud using technologies that you're familiar with. So we're going to use this ugly sample app that I built here to demonstrate some of these concepts.
You're a developer, not a designer.
That's right. Clearly, I am a retro web designer. So what we've got is a simple ASP.NET app that does some CRUD operations against our database. And we've also got some reports that we serve up through the web UI in our interface here. So it's simple app. Let's drop out of that and take a look at some of the things that are available in SQL Server developer tools. So the first thing that you'll notice here is that we have a new node in the Server Explorer, and it's called the SQL Server node. And this is installed automatically when you install our tools. And it gives you the ability to kind of inspect and walk around and check out your database. So the first thing that we'll look at here is this data tier application. So essentially what I've done is I've compiled, if you will, my database, and I've installed it or deployed it to an on-premise instance of SQL Server. And this is somewhat analogous to building a DLL and installing it, right? A lot of people want the ability to have a blessed version of their schema that they install in the SQL Server, and then they kind of hydrate databases from there. And that's what this data tier application framework that Quentin mentioned does for you. So I've registered it here, and then the database gets hydrated based upon that, right? And so you can see here that we've got some tables created, and I can go in and I can inspect the data and, you know, check out the fact that things have already been populated in the system. So what we can do now is talk a little bit about taking this database up to the cloud. So I'm going to switch gears a little bit, pop out of VS, and show you the Windows Azure Management Portal. So this is one environment that gives you the ability to kind of look at all the cloud services that you have deployed and the relationships between each other and to manage them. So the first thing that you see here is that I've got SQL Azure Database up and running. I don't have any databases deployed to this environment yet. Think of this as, you know, kind of like an instance of SQL Server with a lot of the same capabilities, but you don't have to purchase hardware, allocate storage, install software, patch the software, and do all of the hard work that you have to do to spin up a database server instance. Okay, these are kind of, you know, easily provisionable. You can bring them up, grab and go, and pay as you go as well. So we've got a SQL Azure database service running here, and notice here I've also got a SQL Azure reporting web service available. Okay, so I even have something that's analogous to an instance of reporting services now running up in the cloud, and I can deploy my reports up there and use them. Finally, what you'll see is I've got my little web tier here running, and this is the ASP.NET portion of my app, and I've pre-deployed both that and the reporting services component up to the cloud. So having all of these things up here gives you the ability to really rapidly provision these services and use them to build applications very, very quickly using familiar tools and technologies that you already know. So what about moving it to the cloud? I've kicked off a script here, and what this script does is, in 2 lines, we're going to actually deploy that same database up to SQL Azure, and we're going to use a new feature in the data tier application framework that not only moves the schema up there and installs it, but it also takes a copy of your table data, bundles it up side by side with your schema, and pushes the whole package in one shot up into SQL Azure. No more BCPing, no more tedious insert script writing. You just use the data tier application to push the thing up there and you're done. So this is a really nice capability. And while that's running, we'll pop back into Visual Studio and check out some other capabilities that SQL Server Developer Tools offers us. So if I pop open my solution here, most of you probably deal with a common problem, which is dealing with change and dealing with versions of your database schemas, right? And it's a very, very hard problem to solve. So let's assume here that we need to make some changes. So I'm going to pop open this new database project that's installed with SQL Server Developer Tools codenamed Juno. And you'll see here that I've got all of my tables represented as these, you know, little T-SQL code artifacts, right? If I pop open one of these tables, we get this nice new split screen design experience, okay? So if I want to work graphically with my table design, I can work up in this section here. Or if I want the code, I can write the code down here, and we just take care of synchronizing them. I can even flip them or turn one of them off based upon my preferences. All of the other table-specific kind of definitions are handled here as well. So, you know, we all sort of create this table design experience in a very tight way. So let's say the change that we want to make is that we're deprecating a column. We want to get rid of this finished goods column. So I'm just going to right-click on it and say delete. And what you'll notice happens next is an error pops up. We actually had a view that depended on that. If I double-click on the error, it's going to take me to the view definition and point out the offending column so I can blow it away. How did this happen? This happened because SQL Server Developer Tools creates a model over top of your database and keeps track of all of those complex dependencies so you're not breaking yourself when you make your schema changes. Okay, very, very cool. So that's our change. What are we going to do with this thing next? Let's do a couple things to help us version our schema. The first thing I'm going to do here is make sure that I'm only using features that are available in SQL Azure. So when I change my target platform here, SQL Server Developer Tools will just make sure that I'm not doing anything nasty here that's not going to work in SQL Azure. The other thing I'm going to do here is I'm going to bump my version, and I'll just put a quick comment here that this new version of my database schema has a dropped column in it. And probably before we deploy this, we want to do some debugging. So I hit F5 here, and what SQL Server Developer Tools does is use a new capability that we're shipping with Denali called the Local Database Runtime. This component ships in the box with SQL Server Developer Tools, and it gives you a fully functional SQL Server environment without even having to install SQL Server on your machine at all. It's a nice, tight, shared component. And what you'll see here is that Juno, or SQL Server Developer Tools, has hydrated my database. If I do a quick refresh here, we should see that those changes that we just made are represented here. And we can do some testing and make sure that these tables and views and all the things that we're doing actually make sense and work. Right? So now that I've debugged this thing, it's time to deploy it. And I can deploy it right here from within SQL Server Developer Tools, but most environments are going to want you to hand off that deployment to a DBA. And many of you may do that using scripts today. Let me show you a much better way that we're enabling with data tier applications. So here I am in Management Studio. The developer has handed off this new schema to be deployed in the production environment. And what you'll see is, here's my version 1.0 schema that my script completed. It created my database in SQL Azure. And version 1.0 of my product's database schema is here. So I'm just going to upgrade this thing right within Management Studio. And I point it to my DAC pack, which is the result of the build process that we just went through. And you can see it here. And notice I've got version 1.1 of my schema with my drop column, so there's a little visual clue there that we're deploying a new schema. And at this point, the data tier application framework is going to do all the heavy lifting for us. It's currently doing something that really is interesting. It's deceptively simple here, but it's detecting something called drift. Drift occurs when you've installed your nice, pristine database schema, and then somebody else runs in there and dumps stuff all over it, creates new tables, store procedures, and changes things. And drift is a really hard thing to manage, and we'll handle that for you, the detection of that drift for you automatically. So now it's doing something even more sophisticated. It's going in and analyzing what it has to do to get your database from one version of your schema to the next. It's doing it, not you hand reconciling Transact SQL scripts. Okay, so like I said, we're going to start carrying that water for you. And it's even going as far as to say, hey, look, if you proceed with this upgrade, you're going to lose data. Why are we losing data? I deleted a column from a table. So it's giving me a warning here saying if you move forward, data's going to go away. That's exactly what I want. So we'll go ahead and run the upgrade, and the data tier application framework is going to go do all this heavy lifting for us. We'll go ahead and let that thing run, and we'll pop back and look at a couple of other components of my solution while it's running. So one thing that's been something that you all have been asking for is for us to provide both our BI and our database development tools together in Visual Studio 2010. And in SQL Server Developer Tools, we're going to do exactly that. You can see here I've popped open a report in Report Designer. No more flipping back and forth to old versions of bids to do your development. In the future, we'll ship these things together in a more timely fashion that line up with the Visual Studio releases. As a matter, thank you. It's always great getting applause when you're cleaning up your dirty laundry, right? So the other thing about this is we also want those web developers to be able to easily go and find our tools and install them. So we'll ship SQL Server Developer Tools as an installable component within the web platform installer as well. So you don't even have to buy SQL Server or Visual Studio to get these tools, which is really cool. All right, cool. So I've gone ahead and deployed this report to SQL Azure Reporting in advance. Hopefully our deployment script has completed here. Yep, the data tier application framework has successfully migrated to the new schema. And by the way, it did that in place. which is new with Denali. In the past, it used to do it side by side. We'd make a copy, move everything over. That doesn't work for a 10 terabyte database. In-place upgrades do work. Okay, so we finished up here. If we go back and check out our database schema that's deployed, we should see, when I refresh, the new 1.1 schema has been deployed. SQL Server did all the heavy lifting for us, deployed our new schema version up in SQL Azure. Pretty awesome. Right, so at this point, we can go and check out and see if our app is functional. So I'm going to go back in here to my Windows Azure management portal. We see our app is running. I'm going to kick this thing off, and hopefully this thing works, and it looks as ugly as my other app did, right? We have our ugly web page. It does all the CRUD operations, and now we're serving up both our data and our report from cloud services that were provisioned in a kind of grab-and-go way with very little effort necessary. We just purely are building solutions at this point, not worrying about hardware, software, patching, and all that other good stuff. That's all I got. Back to you.
Thanks, Roger.
Yep.
So we talked about cloud in your terms. A big part of course, is the developer experience, and the deployment model allows you to work between on and off-prem, and it's a little subtle because the tools are the same tools, but those tools we're targeting, talking to an on-prem server and a SQL Azure server seamlessly, right? Have the same exact experience, and the tools are able to understand how to target and how to watch out for anything you may have done syntactically that may be different. It lets you work through that before deployment, and then the deployment tools themselves work across the range of on and off-prem products. So we've talked a lot about the sort of the data and kind of the app framework as a whole, and it's clear that as apps continue to evolve, it's going to generate more and more data. But it's not enough. You have to be able to get information out of all of that data. You've got to make it usable. And there are multiple pieces of this. Where are you going to put it all? How are you going to get it to the hands of end users? But there's a piece in between those, which is really about how it's curated. It does you no good to have knowledge being driven out of information if that information is in fact not even correct, right? And this is where things like data quality and master data management and integration services get to the forefront. We're making a lot of improvements in integration services in the Denali release, in the Denali wave, including things like, again, applause to dirty laundry, undo, redo in SSIS, and things like being able to run integration services as a server for a better manageability and availability management experience. You don't have to wrap and roll that all yourselves as a developer. So really taking that to the next level. And also integrating the work we started in master data management and extending that out to domain experts. The master data management, often it's not someone in IT who is the expert in the details of what this data is. It's someone out in the business. And so we're building this extension with Excel to allow that expert to sit in Excel and be part of the master data management solution. And again, integrates back in integration services and the information flow there. And the other thing we're introducing in SQL Server Denali is data quality services, where you have a system that's able to semantically derive through the cleansing of data. And so you configure up rules, it'll recognize things, you can teach it new things, and it'll continue to apply those learnings. And again, that integrates back into the overall information management, EIM processes. The data quality piece of this is critical because you don't necessarily, from every source of information that you get, including web forms, get data in the kinds of formats and cleansed in the right way so you have the right kinds of reliability that the information you're looking at in fact has integrity across the breadth of all the records. So let's take a look at this. I'd like to introduce Elad. Whoops, I'm hitting the wrong button. Elad Siklik to come up and demonstrate DQS.
Thank you, Quentin. Second. Thank you. And what we're going to see in the next few minutes is basically taking a source table and cleaning it with data quality services using organizational knowledge as well as cloud-based reference data. So to set this up, I work as a data analyst for a major service provider that caters for most of the professional sports teams in the United States. And this is a file that I extracted from my CRM database that contains all my account information. So you can see account ID, you can see the team name, you can see the home arena and the address where they play at. And you can very easily see some inconsistencies in the data. There's baseball and MLB occasionally. There's some missing zip codes here. Maybe some addresses are incorrect. And I want to clean this data with data quality services. I'm going to show you just how easy it is. So I'm going to pop up the data quality services client, and I'm going to open a knowledge base that I prepared in advance that is expected to handle all those different columns that you've seen in the Excel. So it has different data domains that relate to the different Excel columns. For example, account ID is governed by a set of business rules. Length should be between 3 and 9 and similar to a regular expression of this sort. There's team name. Team name is a set of organizational knowledge. In this case, it's a list of all the professional teams in the United States: baseball, football, basketball. And then there's the validate address composite domain. This will be used to cleanse addresses. So I have address line, city, state, and zip comprising this. And I could have gone ahead and built a knowledge to fix this domain, but I don't have to. I'm browsing, or I've already browsed, Microsoft's data market, Windows Azure Marketplace data market, and I found a cloud-based provider called Melissa Data that knows how to clean addresses. So all I have to do is map my schema to the reference data address published schema, address line, city, state, and zip, and the data will be sent through the cloud, through this URL to be cleansed in the cloud. And now I'm going to clean the data using this knowledge base. So I'm starting a cleansing process here. I've already set this up. All I have to do now is map my source column from the Excel file to the data domains that I have. And I've already pre-mapped the address-related columns. I will just add the new ones. This is account ID that I will map to account ID, and team to team name, and type to sports type. I'm going to click on next, and I'm going to start the processing. So what DQS does now is reads the data from the Excel and starts all the analysis on it. Some of the analysis is going to be based on the organizational knowledge and set of rules in my knowledge base, and all the address-related functionality is going to be shipped to the cloud through data market for cleansing. In the bottom section here, I can see some initial profiling information on my data. For example, the level of data completeness. I have 8% of data that is missing. The level of accuracy, how many values were deemed as correct or suggested or new or invalid. But the process is finished, so let's go and browse some results. Okay. So looking, for example, at sports type, I found 2 corrected values. MLB was corrected to baseball and NBA to basketball. Looking at team names, there's a correction for the Sixers and a correction for the Giants. Now, actually, those of you who are interested in sport know that there are 2 professional Giants teams in the United States. So how did it know which one? I've built a composite domain rule that looks at the state the team is playing at, and if it's New Jersey, it means it's the New York Giants. If it was San Francisco, it's the San Francisco Giants. There are also a couple of suggestions that the internal algorithm found matching Diamondbacks and Timberwolves and Trailblazers to their correct names. Now moving to the address cleansing part. So here you find a bunch of suggestions that the cloud service found for me. So one center court in Portland was changed to one North Center Court because that is the valid name for the street, while one center court in Cleveland was kept as is. In Minneapolis, there was a missing zip code that was enriched and appended by the cloud service that I was using. Scrolling down a bit more, I can find North 4th Street in Milwaukee that was corrected to a more standardized way of representation based on what I was expecting. So all I have to do now is click on next, look at the preview of all the results that were corrected and suggested, and then export them back either to a SQL server or a CSV file and continue my work. So you saw how easy it is. I could get data cleansing set up in virtually minutes and clean my source. It's very easy to find. It ships with SQL Server Denali, so you can easily get it in your hands of your data analysts or data steward. And it shows the promise of an on-premise solution using SQL Server with the cloud offering of Windows Azure Marketplace Data Market. Back to you, Quentin.
Thanks a lot. So it does you no good to have all this beautifully cleansed data that you've built with an automated process, repeatable, the machine learns for you, correlates the data for you. You've tapped into the cloud by accessing services like Melissa Data through the data market. If you don't, it doesn't do good if you don't have a place to put it that scales, and if you don't end up finding a way to extend it out to the users who really need to get at it. And here we have data warehousing solutions, both just, you can take the box and use SQL to build a data warehouse, and through appliances, shipping SQL Server parallel data warehouse. And then a set of offerings for the end user experience around BI between SQL Server and Office. To demonstrate all this, I'd like to welcome Vaughn Washington to come up and give us a tour of how that works end to end, from the terabytes all the way to the average end user.
Thanks, Quentin. So today I'll show you SQL Server Parallel Data Warehouse in action. You'll get to see its massive performance and scalability, and you'll get to see the first-class BI integration, in particular with Power Pivot and Project Crescent. Let's dive in. So what you're looking at is the SQL Server Parallel Data Warehouse Administrator Console. This is a simple web-based UI that lets you see user activity and all the hardware and software in the system. If we look at appliance state, we get to see all the servers in the appliance. This particular appliance is located in Aliso Viejo, California, and it's 40 active compute nodes. And so it's total of one control rack, 4 compute racks. That's 40 active compute nodes, total of 50 servers. And this screen shows you all of that and the software, the cooling, the power supply, everything in the appliance. This is a very powerful mechanism for managing the complexity of the appliance in a simple view. Let's actually get to running a query and doing something with this appliance. So we've preloaded a data set here. We've loaded this data set up to 0.5 petabyte, largest fact table containing over 1 trillion rows. Quentin, do you know how many zeros there are in 1 trillion?
A lot.
Yeah, that's a good answer. Let's go ahead and run this query. While it's running, we'll switch back to the admin console and take a look at the performance monitor. So from here, you can actually see real-time performance counters in the system. No, the screen is not hung. What you're seeing on the x-axis here are all the servers in the appliance, and you're seeing all their CPU cores actually lit up at 100%. This is an average. We actually can dive deeper if we want. We can see that these servers actually have 2 sockets, that the sockets actually on this appliance have 4 cores on them, and you can see that all of this is being dedicated to answering your business question as fast as possible. Of course, when there's multiple queries running, we'll do the right thing and distribute the load. We've designed the software and configured the hardware to be in parallel from the CPU core to the disk spindle. So you can see that things have slowed down. I'm hoping that means the query finished. Let's switch back. You can see in the bottom right here that the query completed in 47 seconds. In 47 seconds, we just scanned approximately 1 billion rows. So think about what that means for your queries that today take hours. Think about what you could accomplish in that amount of time. That's MPP. So one of the best things about SQL Server is the tight integration between the database and the BI platform. It's just as easy with SQL Server PDW. Let's take a look in particular at Power Pivot and how easy it is to pull data from PDW into Power Pivot. So I'm going to select Power Pivot here, and I'm going to import from other sources. You can see we can pull PDW specifically. I've got pre-configured connection information. I'm using SA. I trust that you're all wiser than me and would never do that. I'm going to select from a list of tables. I'm going to pick a table that we have just landed in the appliance, as well as a couple of dimension tables. And data's coming in, and you'll see actually how seamless and fast, there you go, it's that quick, data from PDW into Power Pivot. What did that take, 20 seconds? That's how easy the integration is. Part of the BI stack is Crescent, and Project Crescent is about continuing the self-service BI journey that we started with Power Pivot. So let's actually switch to a VM running Crescent. So you saw, hopefully, Amir's Crescent demo in the keynote, if you guys woke up early enough for that and you weren't sleeping. So I'm going to go ahead and show you really quickly how easy it is to take data that we created in that Power Pivot model, and then we added to SharePoint, and now we're working with in Crescent. So I'm going to select just a couple of columns here. And I'll point out, actually, as I'm doing this, that Crescent and Power Pivot both sit on top of the same high-performing engine. I think that's the one that Amir referred to as the engine of the devil. Not sure if that's Microsoft he's referring to. I hope not. And let's make one more chart. You can see, much like Roger, I am not a designer, I'm just a developer. But you see how easy this is to do this? And just so you don't forget what we're looking at, I'll add in a title. And let's preview it. And that easy, you get to see the interactive nature of Project Crescent, how anyone with a web browser is empowered to easily access, visualize, and explore data. And of course, pay attention to the right there. You see the interactive nature of it as well. Thank you very much, Quentin.
Great, thanks, Fawn. So we've brought you through the full tour. Starting in mission critical confidence, the investments we're making from the small to the large, things like the in-memory columnar performance engine, the new work with Always On for high availability, a lot coming in the Denali product on just the core fundamentals. Cloud in your terms, it's about understanding that broad spectrum between your on-premise servers, the offerings of the servers in the cloud, and then the new service capabilities, things like data market, data sync, etc., and the programming model, like OData and the development tools, that allow you to start to extend and take advantage of the cloud without this whole hog, rip and replace and move up into the cloud. And last, with Breakthrough Insight, we showed you, the data quality and master data management capabilities and talked about that in the new integration services scenarios. But we also completed the picture where we went from the hundreds of terabytes data warehouse and how an average user with drag and drop and click can actually start to derive real business insight out of the power of all that data that's been through the system. Some things to keep on your radar. Certainly, you can get started today with Azure as a whole. The SQL Azure, the offerings have 30-day free trials to go learn, experiment, etc. The tools we have are coming soon. Some of them are already there. Some of them, will come with a Denali release. The SQL Azure offerings themselves, the database continues to evolve. We've got larger databases coming. We've got backup and other services around it, as well as additional services like reporting, data sync, etc., that we're building around that core database offering. Consolidation and private cloud, again, that spectrum, and there's a lot of customers today building their own consolidation infrastructure and achieving the private cloud value proposition. And part of it is we announced with HP that we're going to develop a consolidation workload appliance for the database that you'll be able to purchase, of course, from HP as an intact, optimized solution. That joins things like Parallel Data Warehouse as these kinds of appliance offerings that are trying to drive some of that cloud value of just plug it in and go and make that available on-prem as well. And then, of course, there's a CTP, another CTP this summer of the Denali release, which will, for us, be a production CTP with our partners and our customers that we're driving those production deployments with. And that really starts the clock, you're getting from the CTP phase and getting it into your hands in final form. So we got a lot coming, a lot on the roadmap. Thank you very much for joining this morning. And as promised, I got you out of here in time for lunch.